Saxon's Calculus Review Lesson B is about more concept review and then geometry review. And because this is so long, I'm going to do what I did with Review Lesson A and split it into two videos. One that's going to deal with Part A and the other that will deal with Part B, the geometry review. So in this one, we're just dealing with more concept review, just like we were reviewing in the first lesson. Now they're changing gears and giving you more. So example 1, find the coordinate of the point halfway between -4 and 7 and 13 and 5. So when it wants halfway between, that's like finding the average of. And so we're going to add the x's and take half. And then we're going to add the y's and take half, and that will give us our middle point. So -4 plus 13 is 9, and 7 plus 5, 12 over the 2. And so this simplifies to 9/2, or you could say 4.5, either way, and 12 divided by 2 is 6. So that is the midpoint between these two. Example 2, find the distance between 4, 3, and -2, -1. Distance should have sent off bells of distance formula, and so I need to remember what the distance formula is. Now typically when we do our square root, which the distance formula has, we do a plus and minus in front, but we're talking about real world dots and lines being drawn, so I can't have negative length of lines. So we won't have the negative part, we will have the square root part. And also remember that the distance formula is based on Pythagorean theorem. Now they do show you in this example more what they're doing, but I'm assuming that you remember well the distance formula and why we do what we do to get it. So the square root is acting as, so I said it was based on Pythagorean theorem, which is like a squared plus b squared equals c squared. So you're solving for the c, hence you're undoing the squared with the square root. And then inside we've got the a squared and the b squared. So however, this is distance, so we're not actually adding. So we're saying our x2 minus our x1 is being squared, that's the a concept, plus our y2 minus our y1 is being squared, and that's your distance formula. So now that we've reviewed where it comes from, oh, they did x1 minus x2, it doesn't matter, as long as you do the order correctly. So let's pull our x2 is -2 minus 4 squared plus -1 minus 3 squared. So -2 and -4 is -6, squares to 36. -1 minus 3 is -4, squares to 16. There's still a square root around all of that. So 36 plus 16 is 52. So the square root of 52. And then I need to split that up. So 2 and 26, 2 and 13. I have a set of 2's, so that's pulling out at 2, and root 13 is left, and that's its lovely simplified. That is the distance formula. Example 3. Write the slope-intercept form of the equation of the line through -4, 2, and it wanted slope-intercept form. Now, I need to remember that slope-intercept has the slope, which is the m equaled something, and the intercept is where I cross the y line, that's my b part. So that means I'm looking to fill into y equals mx plus b. There were a variety of different ways that we wrote this formula: double intercept form, slope intercept form, point form, or point slope form. That's why they're clarifying which one they want you to be using. So write the slope intercept form of the equation of the line through, so this is giving me an x and a y value, that is perpendicular to -2x plus 3y plus 1 equals 0. And I'm supposed to be perpendicular to this one. So my new line, so I have a line and I'm supposed to be perpendicular, which means crossing and forming 90 degrees. So I need to know what the slope of this is so that I can perpendicular the slope. So to solve for the slope, I need to get y alone. 3y equals 2x, I've moved it over, making it positive, minus 1, I've moved it over. Divide everybody by 3. And the only part I care about is the slope, and that's the part with the x, the m. And so now this is what the slope is of this line, and I want the perpendicular. So I'm going to flip and negate it. So my new slope is negative 3/2. And I need to find my b by using this point and then put it in this formula. So the y value is 2 equals, the slope is negative 3/2, the x is negative 4, and I'm solving for the b. 2 equals positive, well, I could reduce this, 2 is in here, 2, so positive 6 plus b. b equals, and then minus the 6, negative 4. So now we plug into y equals, we are using the negative 3/2 and the x, and then we fill in our minus 4. So in your final answer, y and x go back to being y and x, and you just fill in the m and the b. Example 4. Use the point slope form. Okay, so now this one's different because it means point, it's where you have y minus a y number with the slope, and then x minus an x number, and that is the point slope form of the equation of a line. To write the slope intercept form of the equation, which passes through negative 2, 4, and has a slope of negative 2/3. So they're starting me in this to fill in this given information and then change it over to the slope intercept form, this format. Okay, now we know where we're going. So we have y minus, and our y number is 4, equals our slope, negative 2/3, and then x minus a negative 2 is actually plus 2. And we still need to get it to solve for the y, so now I know what I'm doing. Y minus 4, can't make a change there yet, distribute, negative 2/3 x minus 4/3, then plus the 4 to move it from this side, and we're going to simplify. Negative 2/3 x doesn't have a like term. These two are like terms, no x, needs a common denominator of 3, which changes that to 12, so negative 4 plus 12 is 8/3 plus 8/3, and we are in y equals mx plus b. Oop, my box is a little big there. All right, example 5. Write the equation y equals 2/3 x minus 1/4 in double intercept form. So double intercept form, I have to remember, equals 1. So if you have forgotten, go back and pull your notes from Trig for these different formats, or use what I'm giving you to jot them down in your notes to have them however it's working for you. So if I need it to equal 1, I want the x's and y's over here on one side and the number on the other. So let's move this x over here to join the y. Minus 2/3 x equals, and I didn't move this minus 1/4 at all, it's still over there. And I need to change that into equaling 1. So I'm going to multiply it by a negative flipped 4/1. And if I'm doing that on that side, I need to do it on this side, so it's basically multiplying by negative 4 on the other side to keep everything balanced. So negative 4y positive 8/3 x equals the 1. Negative times negative went to positive, and 4/4 is 1. Now, I'm close to having this in double intercept form. I got it equal to 1, but the other thing is that I should have the x first, then the y. I'm just going to flip those when I write it. But it should be x over a fraction and y over a fraction equals 1 to be precise. So I just need to fix. So this is 8/3, and when you move it to be in the denominator, you're flipping it over. So this is x over 3/8, and the minus sign is here because that was a negative. And this is the number 4, and so when I flip it to put it under there, it's going to 1/4. So x over 3/8 plus the y over, you can say plus and then put the negative with this if you choose, or you can write the minus as I did. I'm going to do it their way just because that is the more standard format, but it is okay to have it the other way. Now, example 6, solve negative 2x squared plus 2x minus 7 equals 0 by completing the square. Alrighty, so I know that before I can do completing the square, I can't have a number with my x squared. So we're going to pull out the negative 2 and leave that with x squared. And when I pull out the negative 2, this changes this to negative x. And then this 7 has moved over, and so it's not part of my pulling the 2 out. So the negative 2 is still here, and we're changing it over to our single parenthesis with the squared and our single x written in here. So now you remember in completing the square, it's half it, square it, add it to the other side. So half of this negative 1 is negative 1/2 filled in. Square that to positive 1/4. I'm going to write that over here for a split second. So half it, square it, add it to the other side. However, this 1/4 is being multiplied with this negative 2 before I add it. So then that's going to reduce to negative 1/2. So we're actually subtracting a half on that side. So we halved it, we squared it, we multiplied it by this, we added it to the other side. So now we finish this, and that needs a common denominator of 2. 14 minus 1, 13/2. We've completed the square. Oh, it said solve. Okay, so we've completed the square, but now we need to actually solve. So we're going to remove this negative 2 by dividing it, so we can get our x minus 1/2 squared left alone. And this is implying negative 2 over 1. When you divide, you flip it, so that's going to 1 over negative 2. So this is now 13 over negative 4. And now we can square root to undo the squared. And so we keep our x minus 1/2 equals, and I said earlier, whenever we use, the typical is when we square root, we put a plus and minus in front. So the square root of 13 got stuck. This negative became an I, and the square root of 4 was a 2. Now our last step then is to move this half over to the other side. So that's going to make it positive. It's already sharing a common denominator of 2, so it's basically going to be 1 plus or minus the I root 13 all over that common denominator of 2. Now they left it in one big fraction, in two separate fractions and said 1/2 plus or minus. And then here's the other difference. I will typically write the I in front of the root. They will write it in the back. It's arguable which one is more correct. Mathematicians will say the variable should be at the end. I don't like it there because at quick glances, I can get confused whether the I is or is not in the square root, but either place you're writing it is going to be okay. Most mathematicians will write it at the end rather than in front. All right, example 7. Solve negative 2x squared plus 3x minus 7 equals 0 by using the quadratic formula. So not completing the square, but the quadratic formula. Now, do you remember your quadratic formula? You should. It is negative b plus or minus the square root of b squared minus 4ac all over 2a. The a comes from whatever's with the x squared, the b comes from whatever's with the x, and the c comes from whatever is not having the x. And then you fill these numbers into this formula. So negative b is negative 3 plus or minus the square root of 3 squared is 9 minus 4 times negative 2 times negative 7 all over 2 times a, and 2 times -2 is -4. All right, -3 plus or minus the square root of 9. Okay, negative, negative, negative is going to make it negative overall. 4 times 2 is 8. 8 times 7 is, okay, 48. Is that right? That would take me to 30. I don't feel like that's right. Hang on. No, times 4. 68. Why was I having trouble with that? All right, 68, and then over top of the -4. So 9 minus 68 would be -59. Yes. Yes. Okay. Then I'm double checking their numbers because -2 and -7, unless I've multiplied wrong. Maybe there's a simplify that's getting them to theirs. Okay, hang on one second, then let's just keep working. -3 plus or minus, the inside the square root is the negative, so I'm gonna pull the I out, and that leaves me square root of 59. 59 can split into 3, no, I don't think 3 goes in there evenly. 2 definitely won't. 4, no. 5, definitely not. 6, no. Okay, found my error. Here, when I did 2 and 7 and 14 times 4, just mismultiplied completely. 4 times 4 is 16. 4 plus 1 is 56. I should be filling 56 in here. 9 minus 56 is 47. There's nothing I can do with the 47. So here, that is stuck at square root of 47 all over -4. Whew, okay, so then the last thing is that we don't like negatives in our denominator. So technically they're gonna change this to a positive and make this one a positive, and this positive and negative, when you flip it, they're still that. So if you separate it into 2 separate fractions, it's gonna be 3/4 plus and minus I radical 47 over 4, or radical 47I over 4, either way. And then they also separated it to 1/4 and then multiplied with radical 47I. All of that is the same format of the same answer. So if I hadn't multiplied badly, that one would have worked just fine. Okay, 2 more to go before we stop this video. So example 8 is divide x cubed minus y cubed by x minus y. So that's what they give me. We learned a lot of division methods that shortcutted things, but they're saying to do the long division here of x cubed with our x minus y outside. And then I don't really know what my middle pieces are, so I would have to leave a gap for those and then end it with the minus y cubed. So as we've done before with the division, you start with the first piece and you look and compare it with the first piece. What is missing from x to x cubed? And that is x squared. So x squared times x is x cubed, but then x squared also has to multiply with this one, which is negative x squared y. And we're going to subtract that entire concept. And now I know that what I needed above was a 0 x squared y. So these cancel off. 0 minus a negative makes it positive x squared y. And now we start the process over. Compare this with this. X needs another x, and it needs the y. So we multiply. Xy times x is x squared y, and then plus, nope, sorry, minus here, xy squared. And that tells me I needed a 0 xy squared up here to drop down to be plus 0xy squared minus that whole concept, cancels off. 0 minus a negative is positive xy squared. Start the process all over. What is needed? Well, no x because we already have that, but the y squared, so plus y squared. So that when I multiply is xy squared, and then this one times this one is minus y cubed. Oh, I already had a y cubed, so I don't need to add a 0 term. I just need to drop that one down. So minus, there we go again, minus y cubed. Subtract that whole concept, they cancel off. Negative minus a negative is positive, so negative plus positive are the same thing, is a remainder of 0. So the answer then is x squared plus xy plus y squared. Final example for this one gives me x squared plus y squared equals 9. Oh, if you remember, that's a circle graph. Y minus x equals 1. But thankfully, they're not asking us to graph it. They're asking us to solve it. So we have multiple methods that we learned from before: substitution, elimination, matrices. So we're going to default back to our substitution being the easiest thing. I can't eliminate because this one's n squared and this one isn't, same thing. But we can solve for y here and say that's 1 plus x and substitute that in up in here. So now we keep our x squared plus, and our y concept is 1 plus x being squared equals 9. Distribute. So this is like writing this twice. So 1 times 1 is 1. 1 times the x is an x, and I always double that middle term, so that doubles to 2x, and then x times x is x squared equals 9. X squared and x squared is 2x squared plus the 2x, just keeping things in descending order, and then 1. And if I minus the 9 to bring it over, those like terms will go together, so that would be negative 8 equals 0. All right, now at this point, I either have to factor it or quadratic formula. I also see that I could divide everything by 2, and that's going to drop it to x squared plus x minus 4 equals 0. 0 divided by anything, still 0. Can I split up 4? Let's see, 1 and 4 isn't going to give me a 1. 2 and 2 isn't going to get, so there's no way I can factor it. We have to quadratic formula. So our A is the implied 1, our B is the implied 1, our C is negative 4. So negative B plus or minus the square root of 1 squared is still 1, minus 4 times A times C all over 2 times A, which is 2. Negative 1 plus or minus the square root of 1, a negative and a negative makes a positive. 4 and 4 is 16 all over 2. So negative 1 plus or minus the square root of 17, and there's nothing I can do with that. So that is my answers for, and we were working with x's, so x. So in my, because this is an xy, I know that I've got a coordinate point for my answers. So for the first x, it's going to be negative 1 plus the root 17 over 2. And for the other one, it will be negative 1 minus root 17 over 2. Those are my x values. Now I still need to plug back in and get my y. So here's where it equaled y. So it's 1 plus this answer of negative 1 plus root 17 over 2. So to do that, I need a common denominator of 2, which changes that to 2. 2 minus 1 is 1 plus the root 17 over the common denominator of 2. Now the same thing is going to happen when I do the negative version, so the only thing that's changing is this over to a negative. My common denominator is still the same, so it's 1 minus the root 17 over 2, and that's the two sets of answers. And they wrote it separated into, like this is negative 1/2 plus root 17 over 2, two separate fractions, and the same thing 1/2 plus root 17 over 2. Either way, whether you write it as fraction, fraction, or two fraction, doesn't really matter. You're getting the same answers with altered signs.